Hello you guys, and welcome to another video. Here we're going to be covering yet two more STL functions, copy and swap, and this is used for altering the contents of a container. The container that we're going to be working with is going to be std_vector from the vector library, and let's get started. So here I already pre-wrote some code here. I have a general function here called print vector that's just going to print out the contents of a vector, and I have a main where I create two vectors, q and r. I print their contents. The second vector, when I print r, since it's empty, I'm only going to see an extra new line. But then down here I'm going to implement std copy, but on my own, to copy q to r. So that way now when we print q and r on lines 23 and 24, they should be the same. Then after that I have two numbers, I print out their values, and then I call my own swap function to swap the two values, and when we have it printing here, they should be switched from our print statement above. So with that said, let's get started with the implementation of copy. So copy is going to be a templated function or function template. We'll have a type name, so I'm going to call this iiter for input iter, and then we're going to have a type name for our output iter, which will be oiter. Now what we're going to return is our output iter, and it turns out that we do this because we're not always here in this case I'm going to be able to copy this container perfectly into here, but there are cases where R may already have data. It might have, like, I don't know, 20 values. So when we copy Q over to R, we're only copying the first 4 values of Q onto R. And with that, with the oiter that we're going to return, we're returning kind of like the index, or I guess the pointed position where we've copied our first container to this one, right? Our input container to our output container. But most of the time we don't really need to use the output for copy. That's really used for debugging purposes. So we're going to have our iiter first and last to represent the thing that we want to copy. So we have our copy bounds, and actually this is going to be oiter because this is going to be the end. So we'll have last. Oh no, it should be iiter. Same data type as last. I mean same data type as first. So we have first and last, and then the iiter, which will be result. So here I'm going to have a for loop. I already have my starting condition with first being initialized to the beginning of the container. So we're going to continue while first does not equal last, and then we're going to increment first, and we're going to increment res. And again, this is pre-increment because with these iterators, more often than not, the pre-increment that operator has been overloaded, and not all the time the post-increment is overloaded for these iterators. So in summary, the point of this is to be inclusive, as best inclusive as we can, because for copy, the intended input are any general iterator, and it is part of good practice to overload the pre-increment operator for these iterators. So then, since these are iterators, they're pointing to positions in a container, like an array or vector. So since they are pointers, I need to dereference them, and I do that here. So then we'll have whatever is pointed at first is going to be copied to res. Then we increment both of these, and we continue copying that over. So the bounds of this copy goes from first to last. These two iterators, the input iterators here that I defined. So when I call copy here, I go from the beginning of Q to the end of Q. So I'm going to copy over from the beginning of Q all the way to the end, starting at our begin. And with these positions, they don't always have to be these positions. If anything, I can do something like, do Q end -2, maybe, all but the second to last elements. And maybe I don't want the beginning. Maybe I want to start at the 4th element, copying, Q to R, but we're only going to copy all of the elements of Q except the last 2, and we're going to start copying it at the 4th position of R. right? So with these iterators, you have the control on where you want to start copying and where's that going to end, that kind of thing. But for this case, I don't want to do that. Personally, I don't really. I've messed with this just for the case of messing with it, but in terms of application, this is usually the arguments that I use for copy. So we'll do that here, and then for R, we'll make sure to reserve for numbers, and actually I'll say queue size. So we'll reserve the same amount there, so that way there's nothing funky going on. And then next comes swap. This is the next implementation. And swap, I mean, this is mainly used for like sorting or doing like permutations of containers and stuff like that. And it's a very powerful tool. And like copy, it's going to be a template function. So we'll have our type name, but we'll just have it T here. So we'll have void, we'll have our swap, and we'll get a reference to an A and then a reference to a B. And then here what I do is I have my temp, I set it equal to A, and I say A is equal to B, and then B is equal to temp. And that should do it. So now with these template functions created, why don't we test them and see if we get any errors. Oh, I'm so glad there's no errors. So let's see if we get any segmentation faults. We don't. So this is pretty great. So here, this is going to be Q and R. And actually, I should be seeing two of these right here, but this is empty. So we have a problem there. So let's check if swap works. So copy doesn't work, but swap, it seems like it does, because we have 9 and 5, and then we switch it, and it's going to be 5 and 9. So that's pretty good. So why don't I take a look at copy, and I'll get back to you with the solution. Alright, so I'm back with the solution. So it turns out reserve didn't work. I don't know why. It should have worked, because I needed to allocate, that amount of space for it. But what I did is I created the constructor for the vector with specifying the size. And if you don't know, if you do something like this, we're creating a vector of size 4, right? This vector can contain 4 doubles. Let's say, for example, I wanted to initialize these to all of them to a value of 1. I can do that, or I can say like 1.3. I can do something like that, and we'll keep that. So here I have a vector of 4 1.3s inside of it, and I'm going to overwrite them when I copy Q onto R. So with that, this should work, and you should see with my debugging statements here. So we will compile, we will run. We see that, okay, we have a vector here. It has the values of Q, and then we have our R with 4 1.3 values, and then we copy it over, and we see now that Q and R are the same. And of course, swap was working before already, so we don't have to worry about it. So now that we know that copy works. So fortunately, the problem was not with copy. It was just with how I created my vector container. And now with this out of the way, so this is what's happening behind the scenes when we use functions like std copy, which now we'll be using, the standard template library with their template functions like we should, right? So now I'm using std swap and std copy. So now we'll go here, we'll compile and run, and we see that this all works the same. It works the exact same. And again, the goal of this is to show you that, hey, you should use std copy and std swap. This is how they work under the hood. This is how the algorithms work under the hood here. And I personally think it's important to know how they work, especially with copy, because we know that we actually return the output iterator to see where we last copied, or where the last value was copied, and that can be used for debugging. So if you're having an error copying stuff over, you might have sizing issues or something like that. The fact that copy returns this output iterator is very good, and it's very useful. But you notice here down in main how I don't get the argument to std copy. I don't take its output and store it anywhere. But let's say, for example, I needed to debug. I'd probably do something like, maybe just call it like outres and see what's going on, print out outres, see if it's going where it's supposed to, and that kind of thing. But since copy works, we're good. And again, as a parting words, I encourage you guys to use the STL functions like copy, accumulate, swap, instead of writing your own, just because these have been tested, debugged, that kind of thing. And I don't want to say they're guaranteed to work, but they're more guaranteed to work than what you guys are writing, unless you've been writing this type of code since forever. But this is a good place to start with using functions like this. I mean, if this already exists, you should use it. Unless you have a lot of experience with writing these kind of algorithms, what you write probably won't be as good as this. So why not use the best, so that way you don't run into any problems. Anyways, with that, thanks for watching the video, and I hope to see you in the next one. Take care.